Okay, we're going to start looking at the last sort of features of a sample around the descriptive statistics of a sample. And one of the last things is basically unusual features. So we've talked about the shift in the shape and the centers and all that stuff. Talked about overlap. Now we're talking about unusual features. This is very, very quick go over. It's not particularly complicated. So you obviously identify if there's anything unusual around your graphs. I mean, it could be anything. It could be groupings. It could be gaps in the data. It could be very far out data away from the rest of the data, like this here is. So you basically identify anything that may be unusual, and we use the word unusual unless you want to do some sort of calculation. So in statistics, we don't call something an outlier unless we do some calculations. Now, it's not required that you do the calculations, but if you want to determine if something is actually an outlier uh, to the data, then you have to do some calculations. I'm just going to take you real quick through the calculations and understand that this is not necessary, but something that you may want to do just to add to your story. So if we want to determine if these two data points are in fact outliers, we could call them unusual. They are unusual. They're fairly wide-shouldered males, which can happen obviously if you've got really tall individuals or whatever, but they're unusual. Are they outliers? So this is how you determine if they're outliers. What you do is you find the interquartile range for the box. Okay, you just do the subtraction for the upper and lower quartile and find the interquartile range, and then you do this calculation right here. You take the upper quartile, 48, upper quartile, and add to it 1.5 times the interquartile range. So statisticians determine that 1.5 times basically the spread of the box means that you're dealing with something that is an actual outlier for the maximum outlier. So we do that calculation. We go 48 plus 1.5 times 6.25, the interquartile range. And we get this figure here, 57.375. Now, if we look at this data piece here, this is 57. So basically what this calculation tells us is if anything is bigger, basically, than 57, then it's an outlier. So the actual data point on 57 probably isn't, but this point right here is definitely, this is 60. So that's an outlier. So we can call 60 an outlier. We can call them unusual, but we can actually do the calculation. So anything beyond 57 centimeters is an outlier. So the 60 is an outlier. Okay, so that's how you do the calculation to determine if something is an outlier so that you can actually call it an outlier. Otherwise, you can just say it's unusual. So you could just simply say these two figures or these 2 points are unusual and basically say why they're unusual. You do the same thing if you have data points on the other side, like way over here or something, right? And then it's not adding, it's the lower quartile minus 1.5 times interquartile range for the minimum outlier. So if you want to determine if something on the other side is a minimum outlier, then this is the calculation that you do. So that's just a real quick on unusual features. Again, it doesn't have to be it could be gaps, like we can have a gap in the data. We can have like a strange grouping in the data. So just something unusual, just very briefly discuss why you think it's unusual. And this is the last thing, is what we call making the call based on the sample back to the population. Now, we have to understand that last year in year 12, you would have made the call from the sample based on an informal confidence interval, or based on the 3/4 half rule, based on where the medians are located, and so on. I just want to make sure that you understand how we kind of make a call or make a conclusion about the sample, but understand that at the very end of our sample description stuff, we're going to do this caveat, this beware thing about sample variability. So when you're finished talking about shifts and overlaps and medians and averages and the difference between the averages in your sample, which is your point estimate here, and so on, then you kind of make a decision. Well, what is your sample telling you? So making a call basically means drawing a conclusion about what might be going on back in the population based on your sample. But we already know that basing our conclusion on one sample is really not good practice. And at year 13, we have to do more than this. And this is where this whole bootstrapping, inference, confidence interval, the whole other half, the most important half, by the way, of the internal comes from. All right, by creating a confidence interval and talking about a 95% confidence interval and so on. But we haven't gotten there yet. But we have to keep it in the back of our head that we're getting to that point. So because of sample variability, unfortunately, we know that making a conclusion based on one sample is very risky due to sample variability. So when we state our conclusion, we must be very careful how we word it and discuss sample variability. Now, this has to be in your internal somewhere. And usually, I think it makes sense for it to come at the end of your sample description. Once you've finished doing your description of your box plots of your two groups that you're dealing with. So making a call requires that we look at the degree of overlap between the middle 50% of two groups and the location of the medians and so on. So basically what we've done already around overlap. And you can talk, we've talked about the medians, you would have talked about the shifts and so on. So what is your sample saying? So here in example 1, there's a fair bit of overlap. There's quite a bit of overlap, like between here and here, and you would identify that. So what is that? I don't know. It's almost very close to, it's a little more than 25% of the graphs overlap, right? So a fair bit of overlap. However, no median is outside the box of the other. So the medians are all inside the boxes. It doesn't support the 3/4 half rule here, right? We don't have that happening. So basically the sample suggests that there is no difference between these two groups, that there's too much overlap, there's too much similarity between them. So back in the population, that might suggest, and again, these are very important words that you use, might suggest there's no difference. But because of the sample variability, we can't be sure. Now this is very important. Okay, you can't stop your conclusion at your sample. We have to do more work. So then we come into this kind of conversation about sample variability. Sample variability discussion at the end of the sample description. However, it is not appropriate to rely on one sample to make an inference back to the population due to sample variability. If we took another sample, and now this is important because you got to kind of give some specifics about what you mean. What do you mean sample variability is a problem, right? How is it a problem? Well, if we took another sample, it could be quite different from this particular sample, from this one that we're looking at here, for example. And it could be different how? Well, it could be different in the width of the boxes, so the interquartile range could be different, the median could be different, the mean could be different. So it would tell us could tell us a very different story. Therefore, more investigation is needed. Okay? So when you come to the end of your sample description and you've talked about, shifts and medians and overlaps and shape and all that stuff, then you need to sort of make a tentative conclusion based on the 3/4 half rule maybe, and based on where the medians are, and say, my sample's kind of telling me this, which may suggest back in the population this. However, we're not going to stop here with our investigation because of sample variability, that we know that this is not a great way to make a conclusion. So we have to mention sample variability, talk about what it is, how it affects and impacts our conclusion, and basically leave it at this. Therefore, more investigation is needed because we haven't done the rest of the internal yet. So the rest of the investigation will happen after our holiday break. Okay? And then there's a practice. All I want you to do on the practice is just do question 2 and 3. And all I want you to do is complete 2 and 3 on this sheet, discuss the conclusion you might make for the sample and population, then discuss sample variability, what it is, and how it impacts your conclusion. So you just get a little bit of practice around these two examples as to how you might write the conclusion and then talk about sample variability. And that's it for today.